Welcome dear audience, student and scholars. Here I'm Dr. Amjad Ali. In this video we are going to discuss about organizing and graphing data. Dear scholars, there are thousands of private organizations and individuals. A large number of government agencies conduct hundreds of surveys every year. The data collected from each of these surveys fill hundreds and thousands of pages. In their original form, these data sets may be so large that they do not make sense to most of us. Descriptive statistics, however, supplies the techniques that helps us to condense this data set by using tables, graphs, and summary measures. We see such table, graphs, and summary measures in newspapers and magazines every day. At a first glance, these tables and graphical display presents information on every aspect of life. Consequently, descriptive statistics is of immense importance because it provides efficient and effective methods for summarizing and analyzing information. In this particular video, we are mainly focusing on organizing and graphing of qualitative data. So before going to the further detailed discussion, let's talk about raw data. Dear scholars, when data are collected, the information obtained from each member of population or a sample is recorded in the sequence in which it becomes available. The sequence of data recording is random and unranked. Such data, before they are grouped or ranked, are called raw data. So let's discuss the definition of raw data. Data recorded in the sequence in which they are collected and before they are preceded or ranked are called raw data. Let's discuss the raw data with the help of some numerical example. So here we have information on the ages of 50 students selected from a university. The data values in the order they are collected are recorded here. For example, the first student's age is 21, second is 19, third is 24, and fourth is 25, and so forth. So this table provides us a data set of quantitative raw data. Okay, let's see another example which is related to the qualitative data. Suppose we have same 50 students and we want to know about their status. We want to record their response as in order that here we have F, J, F, SO, SE, JJ, like that. Here F represent the fresh and SO represent the sophomore, J represent the junior, S represent or SE represent a senior respectively. So this is an example of qualitative data. Both these data sets here are called ungrouped data. So an ungrouped data set contains information on each member of a sample or a population individually. So let's discuss the detail about organizing and graphing qualitative data. Okay, for this we first discuss about the frequency distribution. Dear scholars, when we are talking about frequency distribution, a frequency distribution for a qualitative data lists all categories and the number of elements that belong to each of the category. So let's see frequency distribution with the help of an example. Let's see, here we have a sample of 100 students enrolled at a university were asked what they intended to do after their graduation, and we have such type of information like some students are engaged in private companies job, and some students are engaged in federal government job, and some students are prefer state local government, and some are preferring their own business. So here we have a 44 student, they wanted to work for private companies or private businesses, and 16 students here said they want to work for a federal government, and 23 students here wanted to work for a state or a local government, and 17 intended to start their own businesses. So here what the interesting thing to note that we have different type of information here, like in this table we have type of employment as a variable. So here type of employment presents as a variable that is purely a qualitative variable, whereas the number of students here, this represents the frequency column. This represents the frequency column because we have selected 100 students at a university. So the number of students who belong to a certain category is called the frequency of that category. Let's say we are talking about that category. This category is federal government, and its frequency is 16. So this means that 16 students are decided or wanted to join the federal government after their university education. So this table actually represents the frequency distribution table, or a simple frequency table, because here we have a more prominent thing is our frequency table. Okay, let's see another example for the frequency distribution of a qualitative data set. So here we have a sample of 30 employees from a large company. These employees were asked how stressful they are at their job. The response of these employees are recorded as where very represent the very stressful, somewhat means somewhat stressful, and none stands for not stressful at all. Let's see, we have recorded the response of each 30 employees of particular firm. First said he or she feels somewhat stressful, and second said none, third said somewhat, and fourth said very, and fifth said very, and sixth said none. So like that respectively we have recorded the information or response of 30 employees. So here the most noticeable thing is that the variable in this example is how stressful is an employee's job. This variable is classified into further 3 categories, like somewhat, none, and very. So let's make the frequency distribution table of this raw data. We have here frequency distribution table of a stress on job. So let's talk about the arrangement of data. So here we have the main variable, that is stress on job, and we have provide the different categories of this variable: very and somewhat, none. So for getting the frequency distribution of raw data, we make the tally mark. With the help of tally mark, we can get the frequency of individual class as well as the total frequency of whole classes. So the first implied response is somewhat. We mark somewhat 1, and then none we mark in front of none. So like that, when we get the fifth number mark or fifth number response of for particular category, we cross the 4. So this cross represents the total 5 responses are recorded. Okay, we have finally we record the total of tallies of each category, and then we move towards the third column. That third column represents the frequency of a particular class and some of these classes also. So in the first class we have frequency 10, and second class or second category we have frequency 14, the third class we have 6, and the total for 30 implies information is 30. If we sum these frequency, we get 30. So this is the main procedure for making the qualitative raw data into a reasonable form of understanding and getting the frequency distribution of that qualitative data. So let's talk about the relative frequency and percentage distribution. This column, the relative frequency of a category is obtained by dividing the frequency of that category by the sum of all frequency. Thus the relative frequency show what fractional part or proportion of the total frequency belongs to the corresponding category. A relative frequency distribution lists the relative frequencies of all category. We can use this formula for the measurement of a relative frequency. Relative frequency of a category is equal to the frequency of that class divided by sum of all frequency. While talking about the percentage, we have the percentage formula. The percentage is equal to the relative frequency multiplied by 100. So the percentage for a category is obtained by multiplying the relative frequency of that category by 100. A percentage distribution lists the percentage for all categories. So let's see the example or empirical example for the relative frequency and the percentage distribution. So here we have the relative frequency and percentage frequency distributions of stress on job. So here we have the relative frequency, and we know that we get 10, 14 and 6 as a frequency of individual class. So the relative frequency here we calculated by dividing the total frequency of each class, we get 0.33, and by multiplying 100 we get the percentage part of this variable in whole sample or a whole population. So 33.3% of the employees said that their jobs are very stressful. So by adding first two categories, we get to know that around 80% of employees said that their jobs are very stressful, because here we have individual percentage of this category is 46.7. So 80% of employees are very stressful in their jobs. Okay, here one thing to be noticed, that the sum of the relative frequencies is always equal to 1, and the sum of the percentage is always equal to 100, because when we are talking about 1, so this represents the 100% or 100 of a whole selected population. And when we represent some of this, so this represent that each part have a different portion or a part in a population, but the total population is somehow 100%. Okay, let's move towards another important discussion, that is graphical presentation of qualitative data. Dear scholars, all of we know that this quotation, that a picture is worth 1,000 words. So a graph display can reveal at a glance the main characteristics of a data set. There are two main graphical presentations for the qualitative data. The first one is the bar graph and the second one is the pie chart. So let's discuss first the bar graph. Dear scholars, a bar graph made of bars whose heights represent the frequencies of a respective category is called a bar graph. To construct a bar graph, we mark the various categories on the horizontal axis. Let's see, here we have the graphical presentation. We have various categories or various type of variables on horizontal axis and frequencies of those categories on our vertical axis. So we draw one bar for each category such that height of the bar represents the frequency of corresponding category or variable. We leave a small gap, so here we have to note that there is a gap between each category. So this actually this graph this gap makes us to interpret this graph as a bar graph. So we leave space between each category, and there is no relationship between each category. So a bar graph for a relative frequency and percentage distribution can be drawn by making the relative or percentage frequency instead of this frequency on the vertical axis. So sometimes a bar graph is constructed by making the category on the vertical axis. Sometimes we put these category on the vertical axis and frequency on the horizontal axis, depending upon our choice of selection of our variables. So let's talk about the pie chart. Dear scholars, a pie chart represent a circle divided into portions that represent the relative frequencies or a percentage of a population or a sample belonging to different categories is called a pie chart. So a pie chart is more commonly used to display percentage, although it can be used to display frequency is or sometimes the relative frequencies. The whole pie chart actually represent the whole circle, that it is total sample or total population. Then we divide the pie into different portions that represent the different categories. Let's see the pie chart with the help of an example. We have data that we get in our previous slides, that is the stress on job, and we are calculating angle size for the pie chart. Discuss here one thing to note, that a circle contained 30 or a 360 degree. To construct a pie chart, we multiply 360 by the relative frequency of each category. So see here we have the relative frequency, and we are multiplying each relative frequency by whole circle, that is 360 angle. To obtain the degree or measure a size of the angle for each corresponding category. So we have the first category is the angle size of the first category is 119.88. The second category angle size is 168.12, and the third category is 72.00. And we have highlighted here that the pie represent the whole circles, like a circle like that we have the whole circle. So the first, with the help of protectors, we get the angle size of each category, and the pie chart for the percentage distribution, we use this the angle size calculated with the help of protectors. So our first category is taking the angle of 119.88 degree, and the second category is taking 168.12 degree, and the third category is taking 72 degree. So the sum of the whole pie is 360 angle. So our pie chart for the percentage distribution give us the information of the qualitative data set for a particular variable or for different categories as well. So this is all about the organizing and graphing of qualitative data. So see you with another video. Ciao.